All right, so, hello. Any questions? Yes.
I was looking over the syllabus and I didn't see anything. Are your exams accumulative? So like over,
So the next exam, which is a week from Thursday, will not be cumulative as much as it can be.
okay,
I mean, there's some definitions and terminology that you saw in the earlier chapters that'll appear, but it'll be focused primarily on the chapter since the last exam. The final will be cumulative. That's a good question. I should not do a virtual background wearing the screen shirt. It does a great job of green screening.
The bodyless man.
Yes, yes, and the mask too. Yeah, so in my office, also that bald spot up here for some reason becomes. Okay, other questions? So I did post announcement this morning. Some of you are behind on homeworks and quizzes. I know I said I was gonna give you a little flexibility. Catch up this week, please. The grader's gonna hit everything this weekend, and we want to get it all graded before the test next week. So get that all done. There is another quiz posted. There'll be another homework posted too. So, all right. First things first. Oh wait, I'm not sharing my screen. So I was talking about some things that operating systems do. Now, from the more general point of view, and what we typically see when people do system administration work, when people talk about just configuring systems correctly, we worry about operating system hardening. So this is not about the internals of what the operating system does that I kind of glossed over the last two times. Important stuff, but not everybody deals with this. Here, what we want to do is make sure the operating system is more secure. Now, I have a link at the bottom of the page. I will show you that document later and show you what that's talking about. But first, I just want to go over some details here. Part of hardening is really just making it harder for the attacker to get in. And we have these 6 categories that people usually look at, and I'll go over these in more details. But remove unnecessary software, remove unneeded services, alter default accounts, use principles of least privilege, perform updates, and implement logging and auditing. So what do we mean by these things? Every application on your device is a potential target of hackers. And I'm talking about cell phone devices, iPads, desktops, laptops, any computer system that is connected to a network and to the internet is especially vulnerable when it's running, if it's connecting and using services. Each place, quote, application, protocol, device, service, then an attacker can access as part of what we call the attack surface. These are all the places they can get in. You think of a house, right? How could they get into my house? Through the front door, but through the windows, climbing up on the deck. I have a balcony deck, climbing up on there to get into the house somehow. A garage door, you know, they could open the garage door maybe. Through the chimney. Yeah, I don't have a chimney. But through the roof. Now that gets harder because they got to actually rip the roof off and get in. Windows is easier, doors are easier. But I have, let's see, a front door and a back door, garage door. I have daylight basement, so I have windows in the daylight basement, and then I have windows on the main floor. Some of which are much easier to reach than others, depending on what part of the house, because my house is on a hill. So that's my attack surface for my house. If I talk about like how somebody could physically assault me, remember I mentioned that email where there's an assassin after me, right? Well, that assassin could get me at home or on the drive or where I stop and get my sodas. There's 2 places I'm really most likely to get it, though this one was the 3rd one. my parking lot, my office, the classroom. They're all the places I'm commonly found that they could get to me. Rite Aid, they go there a lot for medicines. The grocery store. So these are things you have to think about. It's not just the normal ways people get in. And they will not get in the normal way you expect them to. If you're running a web server, you need to have all of the server software and administration software on your machine. I got to log into the web server and configure the website and update the web pages and everything else. I don't need to run a game on that machine. I don't need to run the standard desktop applications on that machine. That's my web server. That's not my web server and everything else server. Okay. Need to be careful not to remove too much though, since an application may be used by an essential application. And this is where, unless you know what's on the system, you have problems. And there are lots of things running. One key thing that we tell people is you should keep your production machines. These are the ones running your business, your employees or your customers use, separate from your development and testing machines. A developer may download a lot of software and put it on the machine and test it and play with it and then let it sit and move on to something else. I have a staff member doing that right now. We're testing a wide variety of certain, what we call fuzzing tools, which are tools that throw random data at software to try and break it. And we're looking at wrappers for this that kind of instrument the fuzzing. And so download it, test it. Oh, that one doesn't work. Download it, test it. That one doesn't work. Download it, test it. That one doesn't work. Part of what we want. Are these others removed or are they just sitting there? What did they install? If you decide to remove them or uninstall them, do you get rid of everything or is something left behind on your machine? When you're doing this in a development environment, a student environment or research environment, you get a lot of that. Those machines should never be put out for production. When I develop software for people and we want to make it available for production, one thing I do is I fire up a new machine, virtual machine, and try and install it and run it on there to see if I was missing anything. I guarantee you, if you download something from GitHub or any of the other repositories, development tools, and you try to play with them, you install them, they're going to assume you had something on your machine you didn't. And they're, especially if this was not developed for commercial purposes or as a standard package, more as, hey, there's a research thing all the time. And that's what one of my staff members having problems with right now. All the time, hey, let's download this. Somebody published it in a research paper. I guarantee it was a student who wrote it and maintained it, because faculty don't write and maintain these things. And they had something in their default environment that we don't. Okay. Developers who sell commercial products, they do this all the time. They test things on bare bones machines to see if they work. Okay, but researchers may not. And because of that, again, the development machines, the research machines are going to have problems. All right, so just think. And also the software, I'll download the software, I run a service. Maybe I did this a couple years ago on one of my machines. I was testing a different web server. It's probably still there, I don't remember. And I sure haven't patched it or updated it in the years. So it's very vulnerable. I'm going to take that a step further, actually, because this is a problem we've seen in government systems. Developers, these Linux gurus who know everything they're doing, know everything about Linux, quote unquote. This is a quote from one of my friends at NSA. He says they're building a system for us. They say, we want to make it more faster, maybe a real-time control system. So they go in and they tweak the Linux operating system. Then they deliver that product to the US government. A year later, there's a vulnerability in the Linux system they used, and the US government's trying to update this system. And they can't because the developer tweaked the underlying Linux, not just the application running on top of it, but the underlying operating system. They modified it. So you can no longer patch it. And years later, all those vulnerabilities people find in Linux are sitting in this now US government system, unpatched. And he was complaining about this at one point where they're saying, we absolutely need to update the system. It's been 6 years. It's got all these vulnerabilities. It was cheaper to rebuild the whole thing to try and go back and retroactively patch because of what the developer did. Okay, so just think about these things. And they had all these extra services still available in there and code in there that they couldn't get rid of out of Linux that was vulnerable. Okay. We have a lot of services, and many operating systems ship with a lot of services. I may download a standard Linux server and it'll have a web server on it. I'm not running a web server. Why does it have a web server? It has an email server. I'm not running email on this. Why does it have an email server? You know, a lot of times the manufacturers don't know what the customer wants, does not know what the customer needs, and they want to support the marketplace. And the customer doesn't want to, oh, here's my operating system, but now I got to install all these other things and turn on all these things to get my stuff working. I just want to plug and run. So we got the ease and convenience of the customer versus security. And the problem is if the customer goes in and tries to turn off the wrong service, they can break things. And again, if I run my task manager here, you know, I've got all these different applications running on this machine. If I click on services, here's all the services, their statuses, are they stopped, are they running? There's a lot of services on here. Which ones do I turn off? Now, most of these are internal. They're not web services. And so they're not visible to the outside world, so I shouldn't worry about them. We'll come back to that in a second. Nope, there it is. These benchmark guides, the CIS benchmarks, which I'll show you later, can help with this. There are people who spend a lot of time trying to figure out what's the right thing to turn off. Do you even know what's running on your tools or your systems? Right? So let me look at, actually, do I have it on the next slide? Nope. I'll wait till I get there. There's tools such as Nmap and Netstat. I'll explain what those are in a minute. Find out what accounts are installed in your system. You know, I could look at my Linux system, oops, wrong password, and say, hey, who has accounts on here? Let's see if that one worked. Yeah, so I think I'll shrink this window a little. Where am I going? Hold on. Pop open. There it is. Share screen. All right. Hopefully this will pop up soon. Yes. What you're seeing here is I am remotely logged in to a computer to one of our servers. Okay, and apparently it's not responding well. Is that? Oh, sure, it locked up on me just to break things. Well, that's annoying. I'm going to stop share for a second and see if that makes it work now. Okay. Now it works. Let's see if I can get it back working again. Okay, good. So I'm running here. This is a remote, this looks like a desktop, you know, with icons. This is actually running on the server over in Buchanan Engineering. I'm remotely logged in using a tool called X2Go client, and the X2Go server's there. X stands for Xterm, X Windows. It was a remote capability that Linux had for a very long time. All right, that doesn't matter as much. I have a terminal here, a login terminal, shows, you know, and I can like do an ls that shows me my current files. But if I do, if I look at the etc password file, here's all the different accounts on this machine. right? So it starts with root, system administrator, then a daemon, bin, sys, sync. Most of these are default accounts. Actually, all these are games, man, LP, and they have different, this first number here, if you can see it, that 0 is the user ID, and then the second one's the group ID. This is then their default login information. So the ones with no log, they say basically go to this directory and run this program when you log in. So bin bash, bash is something, it's a command line shell, born again shell. And that's where I have this shell, this login capability that you're seeing here. No login says, hey, that somebody with that ID can't log in. That ID only exists for administrative purposes to manage things. But I can look through, and at the very end of this, I see a couple, I see a Jim AF, and then I see a couple other users, X2Go users. You know, so there's a couple other ones sitting around here, but there's not many. So I can look at that. Let me actually do this. Let's do a nmap. 127.0.0.1 is the default IP address for your own machine. It's a loopback address. Just talk to myself. I don't care what my IP address is. Use this one to talk to myself. So I did an nmap, network map, and it says I'm running OpenSSH, or I'm running SSH, and I'm running IPP. Those are the two different protocols that are currently running on that machine. Now, I can request more information, and I think I have it on this terminal, where I had it run a full scan, and it was doing a whole bunch of testing. But what it found out for me, found out my login key, my host key, couple different servers running. It actually did a test and figured out what version of Linux I was running from remotely logging into the machine and figuring that out. Did a bunch of other things. Okay. And so it did a scan. This took a few minutes. That's why I'm not showing how it runs. I could run a command here. Let me go back to the other window. Netstat. Now what Netstat does is shows me information about all the network ports on this machine. Notice that was quite a bit. I'm going to tell it just show me the TCP ones. And so I have SSH. I have, and this is connected from some foreign computer. Is SSHing in to this machine. 129.101.131.17 at port 55223 is connecting to this machine. And another one at machine 20 is connecting to this machine. So I have two remote logins. And then I have this local host to local host. Basically, I'm SSHing in, and then it's going to another port to, actually, I don't know what these ones are doing. That's just to itself for reporting. I could say, hey, tell me what's listening. These are all the services at all these different ports just waiting for a connection. These are deb configuration, socket, Pulse native. Pulse is an audio service, whole bunch of different things, and they're just sitting there listening. If I'd say, hey, just LT, show me the TCP ones are listening, right, versus the UDP ones, it's the, you know, so these other ones aren't TCP or UDP, they're something else, they're streaming services. But I can say, oh, domain name services is running, MDNS, port 631, I don't know what that is. So a couple of these are running, listing. So we have the ability with these tools, when you know what you're doing, to scan and view and figure things out. All right, I'm gonna come back. I think I'll stop share on this one, come back to this, maybe to that VM in a minute. So just, you know, looking at the system, examining things. All right. Knowing what's on your system. Again, typically people have a checklist, they have a list of tools, commands to run, things to say, how do I scan my system and see what's running? Apply the principle of least privilege. Users and programs should only have the privileges, the rights, the permissions they need to get their job done. First place to apply this is with administrator or root accounts. Limit who has access to them. Do not normally run in an execution mode where you automatically have these permissions. So in Linux, typically when I'm running, oops, I just realized I'm probably not sharing the screen here. Yep. In Linux, when I'm running, there's root, and you log in as root. When you're root, you are a system administrator. You have permission to do anything and everything. There's a command called sudo. Okay, SU for super user. The super user do command. Basically, what it says is execute. I type sudo something, and it says run this one command this one time as root. Don't fire up a whole shell. Don't always be logged in as root. Run this one command, and then it asks me for my password. Now, if I'm authorized in the group sudo, I'm one of the sudoers. I'm somebody who's that's one of my group permissions. I'm allowed to do this. If I'm not in that group, I'm not allowed to do this. Only root can change who's a member of that group. In Windows, when I run, I'll run in a non-administrator mode. I want to install a piece of software. It'll ask, hey, you need administrative permissions to do this. Do you want to do this? And type in an administrative password. That's the normal way to do that. I guarantee a lot of people don't do that. And I know, and this just drove me crazy when I've been doing some research with security researchers and I download their tools. They assume you're logged in as root when you don't need to be. Okay, second place, put good access control permissions on your configuration files, on your log files. Third, make sure the default access to user files is for that user only, not for the world. Turn on auditing and logging. Most systems by default have very limited, if any, auditing turned on. It takes up disk space. Each system has a mechanism for doing it. The benchmark guides that I talked about should help with that. And there are different tools companies use to check and review the logs. And so it's like, oh, I need this tool, so I need to configure the logs this way. I'm still not going to show, there's some more links. I'm not going to go to those yet. From Microsoft Windows 10 security. Oh, I have to update that, aren't I? Windows 11 came out earlier this month. Okay, anyway.
Still on Windows 10 gang.
What?
Still on Windows 10 gang.
Windows 11 is not yet finished.
Yeah, I know. Do not install Windows 11 if you have a production system. I am going to put it on one of my test systems over Christmas break. I had no problems. I just installed an update this weekend on my desktop and I couldn't use it all yesterday because of the problems it caused.
Yep.
A new system's even worse. Okay, anyway. You need to also protect against malware. Now, we talked about this earlier, but I'm going to go over this again. Malware is bad software. It's malicious. It's evil. Mal is the prefix for bad. Also just short for malicious, so just think about that. Okay. Generic term for many different types of malware. We have the viruses, which modify your legitimate software, adding bad code to it, usually installed by other malware the user executes. These links here go to further definitions of these things and more details on the internet. Worms are self-replicating codes transferring from machine to machine, do not need a host application. It's a standalone application. Trojans masquerade. Oh, so this is some of the links. I should mention the SQL Slammer. Microsoft SQL service. SQL is what you use to query a database. And so I'm running the MSQL server on my machine, port 443 or whatever port number it was. And it had a buffer overflow vulnerability, which means too big of a data packet would overflow the control, like I talked about earlier. This happened back about 20 years ago. About a 450 data byte packet was all they needed for Slammer. It went in, it overflowed the SQL server, and then it had itself launch against other machines. It spread and infected 75% of the machines it was going to infect across the internet. You know, tens of thousands or hundreds of thousands of machines, I don't remember how many, in 15 minutes. It was by far at the time, the fastest spreading worm. What it did is it picked portions of the network. It looked at IP addresses, did a random mask on it and flooded part of that. Made a mistake. They had a typo in there, so they didn't hit as many machines as they could have. But it still brought the internet to a crawl within minutes. Okay. Trojans, they masquerade as legitimate programs and maybe actually do something useful, but also have malicious intent. Usually arise by email or from a malicious website. Malware of choice these days, you know, things like, hey, your machine's infected, download our security tool to patch it. No, it's not that. It's not a security tool. Your machine will be infected after you download it. Cyber criminals routinely produce these and sell them. Hey, here's a Trojan building kit. We've got everything for you. It'll install the Trojan for you. Just add your malicious software. Then there's hybrids. It's a combination of Trojans, worms, maybe a virus. Bots like the botnets are Trojan worm combinations. They will, you know, the bot may spread and then it installs software in your machine that may look good, but actually is malicious, etc. Very often we have combinations of ways of doing this. You want to protect against this. How do you protect against this? You have virus scanners. You have malicious, you know, software scanners. You shut down the ports. You tell your employees again and again and again, don't click on that link if you don't know who it came from. And even if you think you knew who it came from, don't click on that link. You know, yes, it said it came from my mother. My mother is not emailing these days. She didn't email me when she's alive. She's just not emailing me now. But I got things, quote unquote, from her when she wasn't doing things. She didn't do much except click on those wrong links. Ransomware is probably a Trojan, but it could also be from a buffer overflow or other things. Specific intent, encrypts your data, then holds it hostage until you pay. How do you avoid ransomware? Again, don't click the link. Network scanners, you know, firewalls. What if you get hit by ransomware? What do you do?
Don't pay.
What?
Don't pay.
Don't pay is what he's saying. Then what?
Are you a buy, you hire an outside consultant?
So there are people who have, so a lot of these malware, they'll have a common decryption key. And people are finding these and posting them, and there are possibly ways to get out. Yes.
Might you have a backup?
Backup. That's the best way. Back up everything. Now, here's the problem. Some of these systems think, oh, they're doing backups. So we'll put the ransomware in there, but we'll let it sit for 30 days and we'll infect the backups with a timer. So if you install it after this certain date, that's going to be infected too. Okay, they're backups. It's more than 30 days. Their good backups are now gone because people aren't keeping backups that long. Now we'll infect them. But backups are probably the best way to do this. Fileless malware. It's a specific way deploying malware. It does not use files or file systems, only spreads in memory. So when your computer reboots, it's gone. But as long as your system's up, it corrupts the running process through a vulnerability, creates a new sub-processes, or use built-in legitimate tools. Modern malware does a lot of this because it's harder to, a lot of this, it's harder to detect. Systems are scanning files. Adware exposes you to unwanted advertisements, some of which can redirect you to a lookalike website and can deliver malicious content. Malvertising, not adware. It's the use of legitimate ads or ad networks to covertly deliver malware to unsuspecting users. And spyware, most often used by people who want to check on the computer activities of quote unquote loved ones. Hey, what are they doing? So I know somebody who got some installed because she was really suspicious of her husband, and sure enough, he wasn't doing a lot of child porn. So she turned him in. The tools, antivirus tool, they scan for copies of the viruses. Now they check actually for all types of malware, worms and adware and everything else, not just viruses. They often use signatures. It's a pattern matching or heuristics, best guess patterns to detect the malware. This is type of behavior in your code is normally malware. There's also ones that do, what do we call them? Reputation checks. And so if something bad happened on my machine, the software, the antivirus will flag it and say, oh, this is the software did something bad, and report it to their central host. If enough people download the system and nothing bad happened, that piece of software gets a good reputation check. And so when I download software to install my machine, it runs the reputation check, says, yeah, this one's good. 10,000 people, 100,000 people have installed this without a problem. Yes. And they didn't find any known viruses in there. It's always known viruses. Malware writers, I just type on that, obtain and use these tools to see if they can get around them. I'm trying to sell this tool to everybody out there because I want to make money. Oh, good. The bad guys will buy the tool too and see, does it detect my software? They will use things we call polymorphic code. It's basically different versions of the same code, just rewriting, rearranging things a little so that, oh, I'm looking for this exact sequence of things. Well, it's not there. Self-decrypting code. So it's encrypted, only decrypts after the scanner runs. So it just looks like a data, data in your program, like graphic images or whatever, and then it decrypts it and then runs it. But when it's running, the scanner's already done. Code obfuscation rearranges your code. Malware writers will try to turn off anti-malware running on the system. The SolarWinds attack, Starburst, was actually the attack, reconfigured the default services and then waited. They knew periodically they would do updates and reboot the system. When the system rebooted, it reran the default configuration, so it was no longer secure. It wasn't scanning for things. Then they launched their main attack into the system. They also scanned the system for many different types of anti-malware. They said, hey, are they running these programs? Now, anti-malware tools, like the virus scanners, let's say Norton Utilities, right? Or Sophos is what the university uses. We'll scan the software and say, do I see the word Sophos in this software? It wasn't something we created. Maybe they're scanning for the instance of my package. Well, what SolarWinds attack did is they took the common names and they did a very, very simple encryption on them. An exclusive OR was something. Then when they went through the file system, they grabbed those and applied the same exclusive OR and compared those. So the scanners wouldn't see Sophos in the file name. It was something different because they renamed it somehow first. Clever. They did a lot of clever things. They were spending a lot of time doing this. Actually, how many of you are familiar with the SolarWinds attack or heard of it? Some. Okay, so SolarWinds is a toolkit used by a lot of different companies to help manage their systems. The attackers here got into the company that makes SolarWinds software, this management software, got into their build process so that when they said, oh, we're updating our tools that help the management, the attacking software looked and said, oh, you're updating the tools now, good. don't update the tool this way, change it a little. So they inserted Trojan software, malicious software into the tool just as it was being built and compiled. Now, they were very good. They did much better programming than I see a lot of people do. They had a whole bunch of checks and balances. They would say, okay, did an error occur during this build? If an error occurred during the build, let's go back, undo our patch and rebuild it so it's not detected as a problem. And they had a whole lot of different checks. Is it this version, this version, this version? If anything went wrong, they emailed home. It wasn't email, but they sent a message home so that the developers could update their attack software. They were in there for months. And then this patch, this new version of the software, you know, the developers were constantly every night building it, checking it, making sure it had no errors, running the tests, shipped it out to customers, and tens of and thousands of customers received this, including a lot of government agencies, a lot of big companies. Then they said, okay, now let's go in. All these companies are running this. So let's go to a company that's running this, see if we can get in through this back door. We just inserted it into the code. And this was all about a year ago. It actually came out around Christmas time. So December 2020, we found out about it, January 2021. And what happened is there was a security researcher who was looking at their own system and saying, well, that's odd. The system is communicating with somebody that it shouldn't be. And started looking, they were attacked. They got past all their security tools and everything, but he happened to notice something bad going on and did a lot of investigation and found out what had happened and traced it back to SolarWinds and reported. But several large companies, we're pretty sure the hacking group was based in Europe, Eastern Europe. We're pretty sure they were funded by a nation state to get in and then say, hey, now this information is available, download what you want from US government systems, corporate systems. So a lot of attacks when they get in, if they get in successfully, they're in for months before they're detected. Okay, I talked about this earlier, executable space protection, address space layout randomization on executable stacks, those types of things. There's an old paper called Smashing the Stack for Fun and Profit that gives over the basic ideas. When you build the tools, you have to enable these. Now, most compilers by default enable these protections. Most operating systems by default now enable these protections. A couple years ago, they weren't. You had to force them and tell them enable them. Okay, most now support these things. It's a standard service and they roll it out and they expect you to use it. You can turn them off. You shouldn't. Software firewalls, host identifier, or intrusion detection system, excuse me. Firewalls and IDSs do not have to be just on the network. They exist at the network interface between the operating system and the network card. Usually a subset of what you find in a network-based solution because it's only worried about things to my one machine. Host-based software firewalls can prevent local software from opening network communication channels. I can say, hey, you know, this application wants to phone on, you know, go out on the internet. And it's like, no, you're not allowed. A network firewall will not know if a request to open a connection with a remote machine is legitimate or not. It doesn't know. A network firewall will see my machine requesting a connection to no remote machine. It doesn't know what application is doing that request. My machine knows what application, you know, and I'm running an email service and it's opening a remote connection. Should I? Web browser, absolutely. Other things, maybe not. Host-based intrusion detections look at the software and user behavior and access patterns and say, this is suspicious, something weird's going on. Like I said, the virus scanners scan for things. A lot of these cause me problems as a security researcher. I download stuff I want to evaluate, and the virus scanner says, oh, we found a virus in that, we'll delete it. No, I was examining that. Many of the network security tools can be used for operating system security. Nmap, NetStat, these are the ones I was showing. Now, if the bigger scan I showed, use this, whoops. Actually, whoa, where am I? Nmap minus SS minus SU minus A minus V. So the command was nmap space minus SS. Does a TCP SYN port scan. Basically, hey, is there somebody listening? I'm going to try it. I'm going to actually do a synchronization request, open a request and see if it responds. Does the same thing with a UDP, see if there's anything there. -A does operating system detection, version detection, script scanning, and that's what I showed you. Actually, the output was. -V verbose gave me a detailed output, but that's the one that took several minutes. Works on Windows, Mac, Linux. I used 127.0.0.1 instead of my IP address, but there are vulnerability scanners out there. They can actually scan your system to see, are you configured safely? Are you configured in a way that's known to be a problem? There are exploit frameworks out there that look at running services or applications and say, hey, is there a problem there? Metasploit is a common one tool for this. It's an advanced tool, has a lot of built-in scripts and says, hey, we know this application, it has this vulnerability. Somebody provided a proof of vulnerability, proof of concept. We put it in there, we can now test. For years ago, we had people using this in a lab and we set up an insecure system and had them try Metasploit against it. Haven't done that recently, I'll have to see about that for you guys. Okay. A little more about Windows 10 security. Now, this actually comes from Microsoft. The reference topic that they have in there describes common scenarios, architecture, and processes for their security settings. This is generally for Windows 10 Server. They define a security policy settings. These are rules that administrators configure on a computer or multiple devices for the purpose of protecting resources on a device or network. Security setting extension of the local group policy editor or snap-in allows you to define security configurations as part of a group policy object. Group policy objects are linked to Active Directory containers such as sites, domains, or organizational units, enable you to manage security settings for multiple devices from any device joined to the domain. And the policies are used as part of your overall security implementation to help secure domain controllers, servers, clients, and other resources in your organization. That's a mouthful. You get training on Windows on how to configure these things, and then you understand what they're talking about. But basically, there's a global policy that says these are things you're allowed to do or not allowed to do on these machines. The settings can control the user authentication to a network or device. Who's allowed to authenticate to what? How does that authentication occur? What are they allowed to access? If I'm using Active Directory, Active Directory is a list of resources and contains a list of resources on the network, printers, computers, disk drives, other things. Who has access to what? Do we record a user group's actions in the log? Which actions do we record? Who belongs to which groups? Groups are such an important thing, again, because we want to manage them together. To manage configurations for multiple devices, you can use one of the following options. Edit specific settings in a group policy object. Say, oh, this is the object for this group. Defining the security policy for them. Or use a security template snap-in to create a security template that contains policies you want to apply, and then import it into a group policy object. The template's a file that represents a security configuration, can be imported to GPO, applied to a local device, or used to analyze security. We say, hey, here's the template we should be deploying. Let's have a tool read that and see what we're really doing, a vulnerability scanner. Security settings extension of a local group policy editor includes the following types of security policies in Windows. Account policies defined on devices affect how user accounts can interact with the computer or the whole domain. Account policies include password policy, enforcement policies, lifetimes. These are used for the domain accounts. When you log into the university single sign-on, that's your domain account. Account lockout policy. Wait, what's a lockout policy? When and how long do we lock somebody out so they can't log in? If somebody's pounding on the thing, trying different passwords, Oh, we'll log in as Jim AF, password 1234567 No, that didn't work. 8765432 No, that didn't work. 1234567 9. Oh, wait, he's a computer scientist. 0 No, none of that worked. Okay, how many times can they try before the system says this is suspicious? 3, 5, 30, 3,000, 5,000? And for how long? And again, these are for both domain logging into the network and logging into a single machine. Often that type of policy, just talking about the password one and the lockout, there's a couple of different ones I've seen. A hard number, 3 or 5, and then a timeout like at 30 minutes or an hour before you can try again. Or an increasing time. The first time you log in, it said, nope, gives you immediate response. Second time, it's going to wait 5 seconds. The next time, it's going to wait 10 seconds. The next time, it's going to wait a minute. Next time, it's going to wait, you know. Kerberos policy, this is the Kerberos encryption key management system. So with Kerberos, which I didn't really talk about earlier, you log into the system and said, I want access to that resource over there. It gives me a ticket. A ticket is a cryptographic credential. It says, yes, you're allowed. And it includes information that this user is allowed access to that resource with these permissions for this amount of time. Then I hand that ticket off to the server and it says, okay, you got the ticket. You're allowed to go and use this. And the server doesn't authenticate me. It just authenticates the ticket. Local policies, these are just to a computer, not to the whole domain. Audit policy. What do we log? What security events do we log? What type of, what and where is it logged? User rights. Which users or groups have login rights and privileges on that device? Is it everybody? Or is it just, do we have a local logins allowed? Or do they have to log into that device only from this domain? If they log in through the domain, which groups are allowed to log into this device? Administrator and guest account names. Because it doesn't have to be admin. It can be anybody to be an administrator. Access to floppy disk drives and CD-ROM drives and USB drives and any removable media. So I guess DVD and Blu-ray should be in there too. Installation of drivers, who can do this, what are the login prompts, so on. All this information that's put in there. Windows firewall with advanced security. What are the specific settings to protect the device on your network? You specify using a stateful firewall allows you to determine which network traffic is permitted, pass between your device and the network. Network list manager policies. You know, how do we configure different aspects of how the networks are listed, displayed on one device or many devices? Maybe I can't even see certain networks because I'm not allowed to log into them, so why should I see them? Public key policies, including encrypting the file system, the data protection, BitLocker drive encryption. So BitLocker is really low level, encrypts your hard drive. So when you boot, you have to type in the key to decrypt it before you can open the device. So I do that on my laptop. I do that on my phone. When I reboot my phone, I have to type in a pass key to unlock it. Software restriction policies. Maybe we specify this is the software that's allowed to run. Control its ability to run on my local device, organizational unit, domain, or site. Application control policies. Which users or groups can run particular applications, maybe? Even if this application is allowed to run on all my devices and not everybody can run it. Internet protocol security policies on local computer. You know, we want secure private communication over IP networks. Maybe we'll use IPsec and secure cryptography, you know, cryptographic security. Advanced audit policy configurations can be in there too. Finer control over which activities to monitor as opposed to the audit policy settings under local policies. There's a lot here, isn't there? Okay, so let me go back. So that was from this Windows 10 security link. This one, I'm going to open and I got to share the right screen. CIS is the Center for Information Security. And what they have done is created a bunch of benchmarks or guidelines for securing devices. And they have it broken up by operating system, servers, cloud providers, mobile devices, network devices, desktop software, multifunction print devices. Wait a minute, that's a multifunction printer. Do I have to secure that? Sure, it's running a real-time operating system and services on it, it's on the network. It's a computer, it's running software. It's vulnerable because people don't think about it. So if I go to operating systems here, I have Linux, Windows, Unix, and IBM. Let's go to Windows. And there's Windows Server, Windows Desktop, and Microsoft Intune for Windows. And there's related content. So if I go to Windows Desktop, I don't know if this is going to work. Okay, that one didn't work. So I'm going to go back to, where did I put it? On BB Learn. Okay, let me try that again. See if I actually can get to it this time. And I know the remote people can't see this yet, but I'll share it. So under additional material, we should have the CIS benchmarks. So let me just pick Windows Server 2019. And so this is the benchmark. And what they have in this, let's see if I can, I'm gonna open it here. I hope we're still sharing this. Yes, okay. And their table of contents, they go through account policies. What's the password policy? And I'm gonna just list a couple of these because I think these are useful. Ensure enforced password history is set to 24 or more passwords. So, you know, when you log in and you change your password and it says, you can't use a previously created password. Well, you can't use the past 24 previously used passwords in this policy. That's their recommendation. Maximum password age set to 60 or fewer days, but not 0. 0 is the default for unlimited. Ensure minimum password age set to 1 or more days. Now, we talked about one problem with this. What could be another problem? Why do I want a minimum password for 1 day and not say 1 second or 1 minute?
Because you can do like the recover password thing and just keep doing that, change it to your password, change it back.
Let me close this, I'm not hearing you. I think what you said is what I wanted to hear. Say it again.
So if someone were to try to get into your account and then use the recover password option, they could change your password, do whatever they need to do, and then go back and change it back.
Okay, so yeah, that is the one we talked about last time, was an attacker could change your password, recover, come change it back. What else could happen? Why else would I want to do this? Okay, so standard user Jim loves his favorite password. Standard user Jim hates changing his favorite password. So user Jim says, oh, I have to change my password. Well, here's my favorite password. I'm gonna make it my favorite password 1. Oh, I'm changing now to my favorite password 2. I'm gonna change it to my favorite password 3, 4, 5, 6, 7, 8, up to 24. Now I can change it back to my favorite password because it's not one of the previous 24. And I can get that all done in a few minutes or seconds. Oh, now I have to do it over 24 days. Well, that's annoying. But I could still do it over 24 days. And I know my password's about to change. I'm going to do it on day 1 of the month. Set it to password 1, day 2, set it to password 2, day 3, set it to password 3. Oh, wait, what do I do over weekends? I don't know. We'll figure that out. Users are just, we're protecting ourselves against misbehaving users as much as we are protecting ourselves against attackers. Minimum password length, 14 or more characters. Password must meet complexity requirements. Enabled. Passwords have to be stored using reversible encryption. No, don't do that. Reversible encryption means somebody can decrypt the password and get your original password. You disable that, it's stored using a one-way hash function, a one-way, encryption function. Default is probably enabled. Account lockout policy, 15 or more minutes. Account lockout threshold, 10 or fewer invalid login attempts, not 0 because 0 is infinite. Reset account lockout counter after 15 or more minutes. And then we go into local policies and audit policy, user right assignment. Now the scored are ones that if they come and they evaluate your system and they do, I should have mentioned this earlier, it says scored, they can come and do a site assessment and have tools that actually run and check these things. These are ones that are easy to check and say, hey, did you do this or not? Have you hardened your system? And the nice thing about this, like I said, this is available, this is free. The service where they check, not free. The training they provide to train you how to do all these things, not free. Access credential manager is a trusted caller, no one. Access this computer from the network is set to only administrators, authenticated users, and enterprise domain controllers. Access computer from network set to administrators or authenticated users. So this is DC only, MS only, those are different types of systems. I don't remember what that is. If I click on it, I'm now on page 66. MS is a member server, level 1 member server. And so for each of these things, this policy setting allows other users on the network to connect to the computer and is required by various network protocols that include server message block, SMB-based protocols, NetBIOS, Common Internet File System, Component Object Management Plus, COMPLUS. Recommended state is this. Here's the reason why they want to do this. Users who can connect from their computer to the network can access resources on target computers for which they have permission. For example, the access this computer from the network user right is required for users to connect to shared printers and folders. If this user right is assigned to the everyone group, then anyone will be able to read the files in those shared folders. However, this situation is unlikely for new installations of Windows Server 2003 with CertPack 1. That's an old one, isn't it? Because the default share and NTFS permissions in Windows Server 2003 don't include the everyone group. Although this is for Server 2019, they put in stuff back to when things changed. Audit. To view if this happened, navigate to the UI path articulated in the remediation section here and confirm it is set as prescribed. To establish it via the group policy, configure the following path. So computer, configuration policies, Windows settings, security settings, local policies, user rights assignment, it's access the computer from the network. If you know how to do this, this makes sense to you. The impact, if you remove this user right on domain controllers for all users, nobody will be able to log into the network, domain or use network resources. If you remove this user right on member servers, users will not be able to connect to those servers through the network. Successful negotiation of IPsec connections requires the initiating machine has this right. Therefore, if you see IPsec, it's recommended that it's assigned to the authenticated users group. If you've installed optional components such as ASP.NET or Internet Information Services, may need to assign this user right to that. Here's the default. Here's a reference information for it. This is now certain controls. Okay, what are CIS controls? The Center for Information Security has defined standard system-wide controls for protecting your system. And they will also evaluate people, no matter what operating system you're using or servers or anything else, how you do with respect to these controls. So version 6 is limitation and control of network ports, protocols, and services. That was that control. Version 7, they subsetted it. Version control 9.2, only approved ports, protocol services are running. And so this document, I'm going to go back, let's see. Go back to page 1. I had that, clicked on this. So I'm going to just go through. User rights assignment is section 2. And you can see it's long. Security options for accounts, administrator account status, is for member services is oops, disabled. Let's see. Network client, network server, network access. Named pipes can be accessed anonymously, member services only, network security, recovery console shutdown, cryptography, system objects, user account control, then the event log, restricted groups, system services. This is all short. This I think is in there. You pay more for it. Wired network policies and Windows Firewall with advanced security policies. And they go there. Public policy, private policies, network list manager policies, public key policy. I don't wonder what they're doing there. Section intentionally blank and exists to ensure the structure of Windows benchmarks is consistent. So it could be they don't need it for this system. Let's go back. And just on and on and on. This thing is over, administrative templates, users. Notice shared folders is page 923. This is not a short document. Okay, so I just want you to be aware of that. This is not a short document, but it's very useful. There are reasons these things take time and money to do and maintain. Okay, where's my, I don't want that one. I talked about the controls. They have 18 critical controls. And they break them up actually, usually into a group. At least the last time I saw it, they had the top controls and the sub. But like control 1 is inventory and control of enterprise assets. Know what you have on your system in hardware. Know what you have in your system on software. And so they talk about, oops, no, that's the, okay, that one. Actively manage, inventory, track, and correct all software, operating system applications on the network so that only authorized software is installed and can execute, and that authorized and unmanaged software is found and prevented from installation or execution. Okay, that's fair. Secure configuration, data protection, account management, access control management, continuous vulnerability management, audit log management, email web browser and protections, malware defenses, data recovery, network infrastructure management, monitoring and defense, security awareness skills training, servers, provider management, application software security, incident response management, penetration testing. These are the things they say. If you have a good corporate network, these are the things you do. Like I said, they used to, and I don't see it here, break this up into basic controls everybody needs to do, and then more advanced controls. And so you could say, am I a level 1 security system where I do the basic controls? Am I level 2 that I've done more? Level 3, I've done even more. And I know, for example, U of I several years ago was audited. We hired a company that came and said, let's look at these controls. Which ones do you implement? Which ones do you implement well? Which ones do you implement poorly? Which ones do you fail to implement? Let's go through. Here's our recommendation now, what you should do to improve the security of your network, following these standard controls. If you are a contractor with the federal government, you need, depending on the type of contract, you need to implement and show that you implement some of these certain controls. They don't want government data going out and being given up. They don't want your system, as you're developing software for the government, to be corrupted. So all of these things can be used to protect your systems. Now, what does this mean? For you guys, as a career, there's lots of different things you could look for branching out and doing. One is being an administrator and managing these systems and configuring these, setting the policies, understanding the policies, training people. One could be writing the tools, building the tools, playing with the tools. That's what I love. So how do we, let's talk a little about playing with the tools. I'll talk more about this next time. There's a, okay, where's my, the easiest way to do this is there's something called Kali Linux. Now, Kali Linux is just the Linux operating system with some standard built-in tools to use for penetration testing, security research, computer forensic, reverse engineering. Okay, you can download it and run it many different ways. Bare metal means you are running it on an actual machine. I install it on my laptop and run it on there. There's a version called the live version where I put it on a CD drive or a thumb drive, have my machine boot from that and it runs from there, but it's not actually installed on my hard drive. Or I can install on my hard drive. The recommended way is to run it in a virtual machine. You click on virtual machines and you can download a VMware or VirtualBox version. VirtualBox is a free tool. VMware, free or not free, depending. VirtualBox, it runs on different machines. You download it. Torrent is a bit torrent slow. This is just a regular download. It's a 4 GB download image to your machine and a .ova file for open virtual appliance. And then from VirtualBox, you can import the appliance and it just builds it on your machine. Expands that OVA, takes about, the current version I have takes about 8 gigabytes of disk space. Then I went and installed updates, and I'll show you this later. And then I think it got up to 12 gigabytes of disk space. Now I'm installing every single tool they have. That'll be another 11 gigabytes. But where is it? Where'd it go? They have courses, developers who do things. I had just seen it. Okay, I'm gonna search it right. Let's see. Okay, this was not it. So here's a list of the tools that they put available. And what they have is like the main tool is called GDB, GNU Debugger. But there's some things that are installed with it. If I clicked on this, like G-Core, it shows me, hey, here is what you do. It generates core files for running processes. GDB, here's the man page or help page for the GDB tool. And they provide access to all these for their tools. And their tools are this list. The final exam will cover these tools. So there's a few here. I think when I went to install it, let's see if it's actually finished installing on my, so the remote machine I was logged into, I'm actually running VirtualBox in that machine and told it to install these tools. I'm just trying to see now. Oh, by the way, the user ID is Kali, K-A-L-I, password same. Here we go. I think it was over 1,000 tools installed. When I said, so there was a way of telling it to install every single tool. It has a default top 10 list. It has the common package, which is a couple dozen that people use. That was what comes with it. Like I said, I decided to have fun and said, hey, download Kali Linux everything. And whoops, typo. It's currently taking up 31 gigabytes of my disk space. The virtual machine image. Now the virtual machine has a virtual 80 gigabyte hard drive that, so inside the virtual machine, it says, hey, I've got 80 gig, I've used up so much, I still got space left. The virtual machine has that hard drive taking up real space on my real machine and expands as needed until the full 80 gig is filled. The default, it requires, like I said, probably 8 gigabytes of disk space, 2 gigabytes of RAM, 2 processing cores. This machine I'm running it on has more. It has 20 cores and 128 gigabytes RAM, so I gave the virtual machine access to more. And also, let's see, still has 1.8 terabytes of disk space left. So I thought I had more than that. Oh, that's right. The server has more. I'm running a virtual machine on the server. Then I'm running VirtualBox virtual machines inside the virtual machine on the server, which you can do. So, and that's how I do my research, because then the virtual machine on the server, if I really screw up on my research, I can kill it and start a new one. And then if I really mess that up, that's the virtual machine in VirtualBox, the Kali Linux one. I can kill the whole virtual machine on the server and switch to another one. Because this one is one I'm just setting up to do recent security research on. So, because I've used so many different virtual machines all the time. Because I can just kill them and restart them if I need to. All right, any questions? We're gonna stop there.